All right. Hey everyone. This week we're rescuing an appliance from being thrown in the trash. This hair dryer was this close to going in the trash, but instead of tossing it, I challenged myself to fix it in one day with a 3D printer. No idea if it'll work, but that's the fun part. Let's see if I can design, print, and test a working repair before the day's over. Okay, so let's see what we're working with here. This is the problem. Some time ago, this back screen over the air inlet broke off and it's just been open. Needless to say, it's kind of a hazard. All we got to do to fix it is replace this grill. Okay, let's get started here. Usually I skip over the CAD, but this time I'm going to take you step by step and we'll model and then print this replacement part in one sitting. So first I'm going to do is start with a sketch. And if we look at the part again, just real quick, we can see we've got this circular face that we need to cover. We've got these slots, 3 of them equally spaced that we'll need a tab or something to fit into. And then we've got this circular spot here, this sort of depression where a screen can sit. And so we're going to do 2 parts. We'll do a retention ring around the outside and then a circular screen which will sit on the inside. And we'll print these out exactly the same, but because of the tabs, I think it's going to be a lot easier to have the screen be a separate piece, and that'll allow things to print separately but very nicely. So let's get started. First, let's take a few quick measurements. We'll take a measurement for the outside diameter here, and we're looking at right about I'm gonna call that 61. And for the inner diameter here, we're looking at about 52. I'll call that 52. Okay, but the thing is, with our ring, we're going to need a little bit of a lip to extend over. And what that's going to do is provide a nice surface to retain the screen. So we're actually going to call that, I don't know, let's call it 40, 45, 40. So we don't want to cover too much of the hole because every bit of this that we would cover is going to restrict airflow going through the dryer, and it's going to make it work less good and potentially even be a hazard. So we'll call it 46. And then if we just measure these, we're looking at about 8 millimeters for these tabs, and they are set in. We're looking at about 1 millimeter set in, and they should be about 1 millimeter thick. 1.4, 1.2 millimeters thick. Because I'm printing this with a 0.4 millimeter nozzle, I'll just use a multiple of 0.4. So I'll make these tabs 1.2 millimeters thick, and that way the nozzle will easily be able to print this geometry with a regular flow rate. So let's jump into Fusion and get started. So we have that first circle that we want to draw here. And what did I say? That was 61 millimeters on the outside. Oh, got to plug that in. And then we'll draw the inner one. This is going to be, what did we say? 47 on the inside. Yeah. And now for our tabs, we said about 1 point, we'll set that in 1.1. And for the thickness of the tab, uh, 2.3. And that will, I might have screwed something up. What if it's 1.1? Oh, I see. That is sloppy CAD. So we've got to draw from the same outer. Oh, and there we go. That's what's screwing me up. It's negative 1.1. We're drawing it in from the outer edge. Here we go. Now, negative 2.3. Beautiful. Okay. And then for our tabs, like I said, we have 3 of them. So we're going to do this is 90. We want about 30 degrees. So half of that is 15. 75. And draw this up to intersect. Okay. And then one more. Start here. Oh, and then of course, let's create one more sketch for puck or screen, whatever. We're going to design this just as a little puck and then use the slicer hack of just removing top and bottom layers so that the inside is just infill. And that can actually produce quite a nice screen. So let's see, 50, what did we say it was? 50, 51? 50. Okay, and let's name our sketches now. We have ring and puck. Finish sketch. So to make the puck, all we're going to do is select that and extrude up 4 millimeters, and that is going to be our little puck. Does not look like much here, but once we print that, it's going to look great. So then we have, let's hide that body as well. Let's rename it just so we know what everything is, and we can hide it. Then let's do some more extruding. For the ring, let's two. Going to extrude that down 2 millimeters, and that'll be the thickness of our ring. And then we can show this again and extrude our. We're going to create a new body, and because we already have this sketch on this plane, what I'm going to do is extrude down, then use the same sketch to add the little tab onto the side of it, and then I'll just move that whole body up before we create a radial pattern or circular pattern with this and get these evenly spaced. So we'll click new body and OK. Now if we hide the other part of our ring, then we can draw this down and we'll say 2. And that is our little tab. Oh, actually, which side does that need to be on? I put it on the wrong side. So that's an important distinction to make. I was copying the pattern for these tabs and slots here, but I'm designing this facing upwards, so I just gotta mirror this. That's just a annoying thing to have to keep in mind. Here we go, -2, and join is okay. And let's give her a little chamfer. Just 1.1. And okay, that'll be our tab. That'll bring that up. And now we are ready to create our radial pattern. Let's turn this guy back on and we'll say create pattern, circular pattern. If we select this guy, oh, where are my windows here? Circular pattern. We have this body selected, and for axis, we'll say the Z axis. We can just highlight that and click, and it says, yep, we already have set distribution full. It's going to make a full swing, and it's going to create 3 of these. So That looks like it is spacing them perfectly evenly, and if we want, we can double check on that with some measurements. We can just measure from this face to this face, and well, it says it's a loop area, loop length, 20 millimeters. Sure. Anyways, it should be the same if we go to the next one. Say this guy to that guy. Boom. 20 millimeters, perfect. So these are equidistant here, and this piece is actually, I'm gonna call this done. So one more thing, we'll just put some extra chamfers on here, make that look real pretty, because that's what chamfers do. All right, just a chamfer of 1 millimeter, and so this is one part, and the puck, oh, that's our sketch. Let's hide the sketches. And there's the puck. Oh, one last thing I've got to do is merge these bodies together. It doesn't really matter which one is the body and which one is the tool or target and which one's the tool. They're all getting merged. Okay, so now we've got here, got our ring, and we've got our puck. And all we've got to do is jump over to utilities, and we'll say make, and select our bodies. For this, I will export for now and import both of these into our slicer later. Just save that into downloads. And I'll do the same for the ring. Save. Okay, next we'll jump over into our slicer. So we're going to prepare a new plate here, and we'll just import our new parts. And do both of them at the same time.
At the same time, man.
Actually, just for simplicity's sake, because the PETG I'll be printing these with is really old, I'm just going to do one part at a time, and that should cut down on traveling and therefore stringing. So let's just double check and make sure we've got all the filament in the printer, and then we'll hit slice. All right, let's see what we got here. So we've got our finished parts here. Man, I think this turned out pretty cool. This is the puck. You can barely see inside of that. I went down to 20% infill, gyroid infill. The only issue is that this printed a little bit with a bit of an elephant's foot, so. And hoping that that doesn't, oh, fits nice. All right. And then the ring, this printed pretty perfectly. I mean, I could hear the PETG popping the whole time, but yeah, hardly any elephant's foot and no other deformations. This is a pretty good looking part. We just got to line up our little tabs with the slots here, and then these. Ooh. Oh, nice.
Nice.
And then turn to seat it. Oh, it's not really turning that much. I don't want to force it. Oh no, it did. Oh. Oh. Wow. That's cool. Very cool. Let's give it a try. Wow, you would not know that this didn't come with it. That's amazing. Actually, now for the real test. Let's try this. I can feel that suction. See if we can. Nice. All right, so our part is doing its job. One, my hair didn't get sucked in, and two, doesn't seem to be any loss of airflow. The air is traveling straight through this gyroid infill, no problem. This thing is working awesome. So I'd call that a success. Not bad, for sure. If you liked this one-day fix, hit like, or better yet, subscribe for more practical 3D printing projects. I've got plenty more coming. Thanks for watching, and I'll see you next week. Oh man. Yeah, it's too much fun. Boy, look at that. That fits really well. I can't believe that.